In this part, we will go through a new technique called logarithmic differentiation. Now, what is the goal of using this technique, which we will call it the logarithmic differentiation, is to find the derivative, as we are doing in this chapter, of a function y equal f of x. Now, the problem is f of x could be a very complicated function, which could have quotient, could have a product, power. It's kind of a complicated function. Now, what do I mean by complicated function? Let's look at those three examples here and look at those functions. Look at f of x. Now, this is f of x. Can you see this is a bit complicated function if you would like to find the derivative? It has product in the numerator, it has power in the denominator, especially this one. This one has a power function, power 5, and inside it we have also a quotient which is complicated. And sometimes we have function which we call it variable to the power of variable. For example, x to the power of x minus 1. Now we have a variable which is x here, and we have another variable which is in the top. So we have one in the bottom, one in the top, and this is, we call it variable to the power of variable. Now, all those complicated scenarios need something we call it logarithmic differentiation. So let's go ahead and see how we will deal with logarithmic differentiation, and then we will go through examples finding the logarithmic differentiation. Now, if you take some time to read the steps of logarithmic differentiation, they are 5 simple steps. The first step, it says that we need to take the len of both sides. So we take the len of both sides, we put len here and len here. Next step, this complicated function, if we put the len, we can simplify it using the properties of the len. That's something we have seen before. If we use the properties of the len, the function will get easier and easier. The next step, we will differentiate implicitly both sides with respect to x. Next, we will find y prime, and finally, we will express our answer just in terms of x. Now, keep those steps in your mind. We will do them step by step in one example, and things will become clear. So let me start with the first step, which is taking len of both sides. So this example here, of course, we will use the logarithmic differentiation. So we will use the logarithmic differentiation. So we have many steps. Step number 1, I'll just go briefly with it. Take len to both sides. Now, what do we mean by take len to both sides? Well, just keep y equal x to the x plus 1. Remember, this is variable to the power of variable. So we have a variable here, a variable in the power. So this is something we have never counted before. What we counted was x power 3 or 3 power x, number to variable or variable to number, but we never have been dealing with variable to variable. So what do we mean by take len to both sides? It means all what you need to do, just put len here and len here. Step number 2, simplify the right-hand side, which is len f of x, using the properties of len. What do we mean by properties of len? We know what happened. If there is a len, what will happen to the power, for example? Well, the power will go down in front of the len. That's the simplification I'm telling you to do here. So remember, the left-hand side, I have not changed it yet. Now, x plus 1 will go down, and then you have only len x. Now, this is simplified function. Why? This is just usual len. This is x plus 1. So what we will do in step number 3, take the derivative. Take the derivative implicitly. Why do we need implicitly? Because still I have ln y on the left hand side. Now, what is the derivative of ln y? Remember, derivative of ln is 1 over x, and derivative of ln u is u, and then I put u prime in the top. So what we will get is the following. We will get y, and in the top we should get y prime equal. Now, how do we do the derivative of two functions where there is a product between them? Remember, this is a product between them. How do we do it? Well, the only way to do it is using the product rule. What is the product rule? It says the derivative of first, let me do it in red, times the second plus first times derivative of the second. Now, question, what is the derivative of x plus 1? It's just 1. So all what you need to do, just write 1. Now, what's the derivative of ln x? Just write 1 over x. That's step number 3. Step number 4, we need to put y prime alone. But first, let me just finalize this one here. Go to the next page. In the next page, I have y prime equal. It was ln x plus, you will get x plus 1 divided by x. Now, step number 4, find y prime alone. Those are the steps that we will just keep using them. So how do we do it? We do y equal to y, and now we open a bracket, just write everything there, here. We're almost done, because the last step, return y in terms of x. What was y before? And that's just the typical steps to find the final answer. Write y prime in terms of x. So we ask ourselves, what will be y prime? And what was y prime? It was, we go to the original question, what was y? If you recall, it was x to the power of x plus 1, and that is the final answer we have. That's the final answer. So let me just go all over the steps again. We said we will use logarithmic differentiation because we have variable to the power of variable, something we have not seen before. And logarithmic differentiation has 5 steps. The first step is we take ln to both sides. So all what I did, I put ln here and ln here. Step number 2, I know that if I have a power with the ln, this power can go down in front of the ln. So all what I did, I just take the power down. Step number 3, I take the derivative. Now, what is the derivative of ln y? It was 1 over y, and then you write y prime because this is not x, it's y prime. Here, we use the product rule. Why do we use the product rule? Because there is two functions multiply with each other. The product rule says derivative of first, which is 1, times the second, untouched, plus we do the opposite. Keep the first, now times the second, which is standard ln x, 1 over x. Next step, I have ln x, and then I have x plus 1 with the 1 over x. Step number 4, I need y prime to be alone in one side. So how do I get rid of this y? Just multiply everything by y. Cancel, and then you get this one, which is this. So y can go to the other side. Final step, in the original questions, we know what is y. Just write it down as power, and that's what we get here. And that's the implicit differentiation. We will do another example, which is exactly the same steps. So I'll just go through it all over again. in this example. Now, if you look at this example, again here, let me just write it in one side. Again here, we have variable to the power of variable, which is something we have not encountered before. So how we will solve it? We will use the logarithmic differentiation. Now, what is the logarithmic differentiation? Well, there are many steps. Step number 1, we have to take len to both sides. And that's a good step. We can do it. So we take len to both sides. So what we get? We get y equal, we have 3x power square root of x. All what you need, just write len here and don't forget in the both sides. Step number 2, simplify the len of the function. What do we mean by simplify the len of the function? Remember, one of the properties of the len, if we have a power, we can take it down. And that's exactly what I will do. I'll just go ahead. Y equal, take the power down, so you will get just root x, and here you will get just 3x. Now, this is much simpler function. This is just a product of square root and len. So this is something we can find the derivative easily. So step 3, differentiate implicitly. What do we mean differentiate implicitly? Means what is the derivative of len y? Remember, derivative of len y is we write in the denominator y and the derivative in the numerator equal. Here we have to use the product rule, derivative of first times the second, plus the first times the derivative of the second. Now, we ask our questions, why did I do this? But remember, because there is a product between them. So I use the product rule. Now, the question is, what's the derivative of square root of x? Well, this is one of the formula that I told you to memorize. It's one of the formula that's famous. Square root of x is just 1 over 2 square root of x. Now, what is the derivative of len 3x? Remember, you write 3x in the denominator, and then you write the derivative of 3x in the numerator, which will be just 3. So you can just write it as 3x, and then you have 3. Of course, there will be cancellation, 3 with 3. Let me just write this one in a better way, and then we continue with it. So here we have y, y prime equal, we have len 3x divided by 2 square root of x, plus we have square root of x divided by x. Why is that? Because 3 with 3 get cancelled. I have only root x and x. For me, just keep them as this. Don't try to simplify it further. Step number 4, find y prime alone. And that's step number 4. Now, what is y prime alone? It's equal to y, and then we have len 3x divided by 2 square root of x plus square root of x divided by x. Step number 5, write in terms of x. That's it. What is y prime in terms of x? So all what you need to do is go to the question itself, remind me what was y, and I will write it down there. Well, actually, y it was 3x to the power of square root of x. That's the final answer for our questions. So if you can recall, it is the same step we did before. We take the ln on both sides, and then we use the properties of the ln to drop the power. So we keep the power here. Next, we differentiate. What's the derivative of ln y? It was you write y, and then you write the derivative of y in the numerator. And here we have to use the product rule because we have two functions, square root and ln. So we take the derivative of first times the second, plus we do the opposite, first times derivative of the second. Now derivative of a 3x, you write a 3x, and then in the numerator you write the derivative of 3. So you get cancelled, you get 1 over x. You simplify it like this. However, I don't want to see the y here, so I move the y to the other side. It becomes here. And finally, we just write y alone. So we write, instead of y, from the question, we write it as this one. Next step looks similar, but with a different flavor. So let's just go ahead and do it here. So again, it's the same step. Now, this is again a variable to the power of variable. So we'll have to use, we will use the logarithmic differentiation. Now, what is the logarithmic differentiation? Remember, the first step is we take the ln for both sides. To both sides. Now, what is the ln for both sides means? It means just put ln here and ln here, keep everything as it is, and then we will think about it, what we can do. Well, now, by the properties of the ln, this power can go down. And that's the nice thing. So in step number 2, we use or simplify using the properties of the ln. Let's simplify as the properties of the ln. What we will get is ln y. First of all, the first power is ln x, and then we have another ln x. Remember, here we have to be careful. We have ln x and ln x. So just keep it as this. Now, the next step, step number 3, differentiate implicitly to find y prime. What do we mean by differentiate implicitly? It means just write y here. In the top, you need to write y prime equal. Now, because we need to use the product rule, we have two functions multiply with each other. So what we will do, we will use the product rule. Derivative of first times the second. What is the second? It is ln of ln. So we have ln x plus the first, which is the first ln, times the derivative of the second. We'll see what's the derivative of the second in a minute. Now, we ask ourselves, what is the derivative of ln x? This is one of the standard one. It is 1 over x. So far, so good. Ask yourself, what is the derivative of ln whatever inside it? Now, forget whatever inside it. Well, it is 1 over u. Now, this is, we call it u here, divided by, and then we take the derivative of u. So that's the whole idea here. So we'll have it like this, u, and then 1 over u. Well, this is, we call it u. So we need to write u, and then we write u prime in the top. So let me do it just like this. So this is u. And in the top, I need to write the derivative of u, which will be 1 over x. Of course, you can simplify a bit here. Ln x with ln x get cancelled. So if we go to the next page and we rewrite everything, we get this one. This is y. This is y prime equal. Now the first one was ln of ln x divided by x plus 1 over x. Why 1 over x? Because remember, we have ln with ln get cancelled, and the only thing remaining is 1 over x. So far so good, because now the fourth step, step number 4, what we need to do is very simple. Just write y prime in one side alone. What do we mean write the y prime in one side? How do we do it? We move the y to the other side. So we get y, and then we have ln of x divided by x plus 1 over x. Step number 5, write y prime in terms only of x. Write y prime in terms of x alone. Which means we will get y prime equal to, remember, y from the question, it was just as, so we have ln x, remember, y in the question was only written that way. And that's the question here for. All right, we continue with example number 4, where we need to find the y prime of, now this is a different function. This is not variable to the power of variable, but this is kind of complicated function. It has power, it has quotient. Of course, we can solve it with the chain rule, with the quotient rule. It can be solved, that's fine. But let's use the logarithmic differentiation so that we see how things will happen. So in logarithmic differentiation, if we want to use it, there are many steps. Step number 1, we will need to take the length for both sides. So all what you need to do here is you have a big square root of 5 minus 4x divided by 1 plus x squared. That's the first step. Now, how you do that? Next step, you need to simplify this one. Now, let's see how we can simplify this one. Well, the first thing, we know that the square root can be written as power half. So if we just write it down, and then I will rewrite it as power half. So we have ln, and then we have a big bracket to the power of half. Here we have 5 minus 4x divided by 1 plus x squared. Now, we know what will happen to the power half. It will go just down. So just let me write it down here. Get half. And then we have the ln of the quotient. Now, also we know what happened to the quotient. We can take the ln for both. So the answer will be half. We can take the len of the first one, len of the second one. So here we have 5 minus 4x. Here we have 1 plus x squared. And then, don't forget, we put a minus between them. If they are multiplied with each other, we put a plus. If something in the denominator, it goes with a minus. And that's exactly what is len y. So just let me write this down in the next page, and then we will find the derivative. So remember where we arrived to. We arrived to len y on the one side equal half of two lens, the first len and the second len, and there is a minus between them. This was 5 minus 4x. This is 1 plus x squared. Now take derivative. What's the derivative? Well, derivative of len y is just y, and then we write y prime at the top, equal half. Now, what is the derivative of this len? Well, the derivative of this len is 5 minus 4x, and then you need to write the derivative in the numerator, which is negative 4. Next, we have a minus. Same thing, we do it here. And we write 2x. The last step, we just need to find what is y prime equal to 1 over 2 y, and then everything we wrote here. 5 minus 4x minus 2x, 1 plus x squared. The last step, I just skipped the last step, should be this one. Just copy it. Here. And finally, we just need to write y alone. So just take this one here, copy it, and paste it. The only difference now you need to do is you need to change this y back to what it was before, which was 5 minus 4x divided 1 plus x squared. And that's it. While I didn't use quotient rule, I didn't use the chain rule, I just used the len and the idea of the logarithmic of len. So properties of len can simplify the questions further and further and further until no more simplification is required. Now, example number 5, which is exactly the same question as before. Remember, this is even more complicated function. If you try to do it with the chain rule and the product rule and the quotient rule, it will take a long time. Let's see how much we can save using the logarithmic differentiation. Just really a scary function. Well, the first step, we need to take the len of this. So if I just write it down, and let me rewrite the root once for all. So if you write the root, this is 1 over 3. Here we have 8 minus 9x. Of course, don't forget we have a len. Now, what will happen if we have a len? Well, too many things will happen. First of all, the len will get into the first one, and the power will get down. So we will get 3, because the power will get down. Just here doing it a little bit quick here. And we take the len of the first bracket. Plus, do the same thing for the second bracket. The 7 will get down, and we take the len of the inside. So we get 7 len of whatever inside. 4 plus 5x power 6. And then we have a minus for the last one. And the power will go down, which is 1 over 3. And then again, we have a ln of 8 minus 9x. So we have those 3 items up here. So just let me write them down here again, because I will take the derivative now. I'm ready to take derivative, so just this is ln y. And now take the derivative. What is the derivative of ln y? Well, we know it is just y, and we write y prime on top, equal to. What is the derivative of the first ln? Remember, derivative of ln is u, and then you write the derivative of u in the top. So the 3, we don't need to do anything with the 3. We have 1 plus 2x. And now what's the derivative of the denominator? Just 2. Plus 7. We do the same thing. 4 plus 5x power 6. And then we write the derivative of the denominator, which is 30x power 5. Finally, we have a minus. We have 1 over 3. 8 minus 9x, what's the derivative of the denominator? Just minus 9. Of course, this one can be simplified a bit. We get 6 over 1 plus 2x plus 210x power 5 divided by 4 plus 5x power 6. And then we have a plus 3 divided by 8 minus 9x. All of this, we get it here. Let me just copy it, because I will just keep copying it again and again. Next step, we need to find y alone. So you just move y to the other side. And then you just paste what you did before. Last step, return y to what it was before. So what was y before? It was something like this. I think this is 7, this is 3, divided the third root of 8 minus 9x, 1 plus 2x, 4 plus 5x power 6. This is what was y before. All what you need to do is just whatever we paste before, we write it down with it. And that's it. And that's how we find the logarithmic differentiation.